All right, so this is your lab report for the first lab, density of an unknown metal and the density of water. For that lab report, page 1, I want a lab rubric. This can be found in Canvas. Go to Files, lab rubric number 1, download it. That'll be your first page, put your name on it, and I will grade that page along with the others. It gives you the rubric. Page 2 is your lab report form. This can be downloaded from the chemistry website, same place you got your procedure. I'll show you that in a moment. Page 3 is going to be your graph, has to be computer generated. So you will have both axes labeled and a title. Make sure you do that. I picky about it. So mass in grams versus volume in mils, and a title. So look for those. And then you will put a trend line. So you're going to have those points. Make sure you do this in a scatter plot, and then you're going to right click and add a trend line, and that'll be y equals mx plus b. Make sure it shows up on there. So you'll select linear trend line and then select to make it visible on the actual graph. Then pages 4 on, representative calculations. That means every time there's a new calculation, you'll show me how you did it, but I don't need to see 10 of the same calculation. Make sure you include average deviation. It does ask you for that. That's in the preamble of the lab. I'll show you that in a moment. And then the last page is the carbon copy of the data so that I can make sure I see your data. Just in case you transpose a number erroneously, I can still find that. We're going to come back to here. You'll notice this is from the chemistry website, chemistry.mercer.edu. You'll bring this up, select the general chemistry tab, go to the 111. This should look very familiar. This is where you got your description. I'm going to the description. It has valuable information, average deviation. That average deviation calculation information is right here. It gives you the formula as well as all of the pieces in terms of what the average value x is, etc. So this shows you exactly how to calculate that. We're not doing a standard, so it is not a standard deviation. We don't have enough data for that. And then at the very end of this description, this is your chart with all of the unknown metals in it. So it narrows the choices that you have. So once you get your density, if you have a density close to 2.7, then your metal should be aluminum. You can also look at it. You've got some description that you could note about its, how it feels or what it looks like. It's very heavy, for example, and it's colored. It's more orange in color. You probably have copper, and I bet your density is close to 9 or 8.96. So the lab report form itself is in the same spot. We come under, and it's under the lab, it's under the description. We click on that. When you come down, notice here's your first set of data. You're going to put exact volume here. So this is from your burette. You're going to make sure that you subtract your initial volume from your final volume on these. So this should be roughly 1 mil, 10 mils, 25 mils, and 50. The mass of your top loading as well as the mass of your analytical. Make sure that you subtract the mass of your beaker from the mass of the beaker plus the water that you added. So your volume here is roughly 1. Your mass here should also be 1. If it's much larger, you forgot to subtract the mass of your beaker. Same here. If the volume's close to 50, these masses should be close to 50. You'll do your average and your average deviation calculations. You'll fill all this information in. And then on the second page, you can X this out. We're not going to do that section. And then underneath it, it says identify the unknown metal. Make sure you fill this out. I need to know what the density is. Make sure you've got your calculations just in the order I noted, your unknown number, and then you're going to identify your unknown. I need that information, your unknown number and the ID, so that I can grade that part. And then the last piece, you can forget this. You don't have to fill that out at the end. You can exit out as well. So do 1 and 2, but not this piece right here. All right, so now let's talk about calculations. In part 1, you actually found your graph. And from that information, you could get the density of water. And it should be close to some of your calculations. It's literally going to come straight from your graph. The slope of this, because it's rise over run, is going to be the density of water that you will use in part 2. So your density of water comes directly from that graph. Now, the second part is the density of the unknown metal. We've got an empty flask that you have a mass for, and then we've also got a flask here plus water that's completely filled with water, and you have a mass of it as well. That's not gas, that's actually a mass. I'll put an equal sign there. And then here we have a flask that has the flask plus the unknown metal that you had, and there's a mass with that too. And then the very last one is your flask plus the metal plus the water that you've added above. So here's your metal, and you've got the water that's filling the area, or rather the volume and the spaces in between and the rest of the flask. And you have a mass associated with that. So we've got masses of all of these. Now, the mass of your unknown metal is pretty straightforward. You could do it a couple of ways. You've got an empty flask and a flask plus metal. Now notice the only difference is the metal. So you could very easily make a quick, easy subtraction and get the mass of your unknown metal. Now the next part is not as intuitive. It's the volume of the unknown metal, and we're going to look at that. If we could find out what the volume of this flask is, that would help us, because that would tell us how much metal displaces this flask here. So if we could find what's the volume of the flask here, and I'm going to put it, if you will, above the metal, or unoccupied by that. So we're really looking at it. Another way to put it is, I'm going to write it this way. I think this will be a little more helpful. This is the volume of water above the metal. So the metal displaced some of the water from the original. If we could figure that out, we could get the volume of the metal of that. So how we're going to do that is we can look at the density of water is equal to the mass of water divided by the volume of water in this flask. In essence, this is really going to be the same. These are synonymous when I'm talking about volume here, because it's occupied. Now the flask is going to have a dashed line on it, and it's going to have a volume, but don't use that. It'll have some volume associated with it. That's not the true volume, full volume of the flask. You need to know how much water is occupying that. How you'll do that is you've got a density of water that you get from your graph. You could figure out the mass of water, a mass of water in there, right? Because you have an empty flask and a flask plus water, so the only difference here would be the water. So through an easy subtraction, you could get that. And lo and behold, that will then give you the volume of the flask, or the volume of water occupying the space inside there. Now the next piece over here, we're again going to do density is equal to mass over volume. And again, we're going to use this as water, but again, it's really inside the flask. The water's occupying it above the metal, so above metal. And here we're going to look at mass of water, and again, this is going to be volume of water above the metal, if you will. So we will again use, and I'm going to use density of water here rather, and we're going to use that straight from the graph. Got a little overzealous there, because that's straight just density of water. That's not going to change unless the temperature changes. Now the mass of water that's occupying this flask we can get, because we have flask plus metal plus water, and we have only flask plus metal here. Now notice the key difference is water. We can do a little basic subtraction there and get the mass of the water, and lo and behold, that will give me the volume of water that's occupying the space above the metal, because the metal displaced some of the water out of there. If we do a subtraction between those two, I will get the volume of my unknown metal, right? Because here I have the full volume, here I have only partial volume, and what's left would have to be the volume that the metal is occupying. And lo and behold, that would be the volume of my unknown metal, and I've got the density of my unknown metal, I can identify it, and I'm well on my way to finishing my laboratory.